Well, good morning, guys, and welcome to the show. What do we have today, Fernando?
We have a product review, guys.
That's right. We have some new Wav Tech products that we're going to talk about. You ready?
I'm ready.
Let's get started. So a couple months back, we had Nick from Wav Tech on the show. We talked about some of their cool high-level, low-level products, and we were like, man, we can't wait to get around to reviewing some of these. Well, we're getting around to reviewing some of those.
Yes.
I know, right? The reason why we wanted to talk about these products is because factory integration is becoming more and more and more. Well, quite frankly, that's what it is.
Correct.
Integrating into that factory radio has become so important. Now, whether you want to do a big system with the DSP and summing and all that fun stuff, or you just want to add a subwoofer, or you just want to add an amp to your mids and highs to improve the way it sounds, if you're keeping the factory radio, you're going to need some way to do that. Wav Tech makes solutions for those. We've got a couple of them. Let's take a look. So what we have for you are 3 different solutions depending on what you're going to try to do. Now, they make other products than this. These are just the 3 we're going to focus on. This is going to be part of a 3-part series where we're going to go ahead and review each one of these individually because we're going to put them in the car. We actually want you guys to see how these things work. We have just a standard, and I use the word standard very loosely, high-level to low-level adapter. We have a high-level, low-level adapter that's going to be for your subwoofer. And then we have this guy here, the Link T, which is what we're going to be focusing on today, that has time correction built into it. So let's go ahead and unbox this guy and see what comes in the box. Now, the first thing in the box is going to be the manual. Now, Wav Tech keeps all their manuals listed on their website. So if you want to go check one of these out before you buy it, you can download their manual and take a look at it. Just like this. Now you can find their website at wavtech-usa.com. Now naturally you're going to want to read this manual to figure out everything it does, and I mean it. On this one you really got to thumb through that. Well, unless you've watched this video, in which case, okay, you get the idea. A piece of foam, and then the piece itself. Comes in a bag. Take the bag off, move the box away. Let's go ahead and take a look at it. Now, one of the things I really like about Wav Tech is their build quality. These things are made out of aluminum. Their RCA ends screw on. They have removable brackets here, so if you want to mount it somewhere and these are in the way, you can go ahead and take these off. These are all nice and rounded, so you don't have to worry about doing things like this when you put one of these, ow, quit, stop. Now, the other thing unique about these are their connectors. These look a lot like everyone else's connectors, but they are different. And how are they different? Now, if you take a close look here on the end, you'll see that it has this little triangle on top of the square there. The reason why that's like that is because there's little teeth here in the top of this. So when this goes in, it's designed to lock in place and not move left or right. So this makes it very strong and very hard to remove. So when you put these in, you push them in, and then you actually have to pull these things to get them out. This is nice because if you're going to mount this someplace like behind a panel, in a dash, or tuck it somewhere, you don't want these things falling out. So let's go ahead and remove the top and we'll take a look inside because that's where the magic is. Now, they do use Allens to put it all together. So here you are. This is what it looks like on the inside. Now, if you've never seen the inside of a high-level to low-level adapter before, you might think, what am I looking at here? Looks okay. We have a standard high-level to low-level adapter, so you can see what the difference is. Now, this is a passive high-level to low-level adapter, and by passive I mean it doesn't require any power or ground for it to function. It uses a couple resistors here, as well as a couple transformers. This is designed to choke down the sound so that it can then be passed out through these RCAs and go to your amplifier. As you can tell, this may not be the best way to do it, but it has been what we've been using for years and years. These guys do it a little bit differently. This actually requires a power and ground. As you can see, there's a transformer right here. This does it electronically. Along with this being a high-level to low-level adapter, this also is a line driver. But by building it like this, what that guarantees you is that whatever signal is coming into this is what's going to come out of that. Now, I know what you're thinking. Well, doesn't this do the same thing? Well, no, because this is choking that signal down. There's going to naturally be some form of colorization and or loss because you're crushing that signal. This is a much better way to do it. Now, before we put this back together and talk talk about all the specs on it, there is one thing I wanted to show you. This right here. This has balanced inputs, but for some reason, if you need to switch it between balanced and unbalanced, there's two jumpers right here. You just simply raise up and move down, and that will switch it from one to the other. So on the end here, like we said, they have the screw-on Tiffany style RCAs. You have your inputs here and your outputs here. This is a line driver, as we said, so you can use this on, let's say, an aftermarket radio that doesn't have a very good output before you go into the amplifier. So if you want to get a better signal going into the amplifier, let's say you want to get that 4, 5, or up to 10 volts of output with this, you can. So if you're going to drive multiple amplifiers and you want to increase your output voltage, this has 10 volts of output. Now over on the other end, of course, it has your speaker level input here, and then it has your power input here. Now this is going to take a constant 12 volts, a ground, and it has remote input and remote output. Now the reason why it has remote input and output, so depending on the type of system you're going to put it in, let's say that aftermarket radio that you're going to plug into here because you want more output voltage, you'd run the output remote turn on into the input of this and then output to your amplifiers. But let's say in the case that we're going to show you the install on, we're going to be using high level input. This will go ahead and generate its own remote turn on using either DC offset or signal sense. This will allow you to not have to go dig through and find an accessory. It'll create one for you to turn on your amplifier. Now let's go ahead and talk about some of the specifications that this unit has. It's a 2-channel digital time alignment processor. It has low impedance output. It has differential balanced inputs, independent gains with clip LEDs. And let's stop there for a second. It has a left gain and a right gain. And that's important because like we said, this has time correction built into it here. But these guys are clip light indicators. So that means you don't need any cool tools in order to set clip on this. You just simply find the clip on your radio. Once you've found that, you can turn this up and these clip lights will turn on when the signal is no longer clean. And then you just back it down to here. But don't worry, we're going to show you how to do that. This also has OEM load detection. So in a lot of the new vehicles, they need to see a speaker load in order for the radio to stay on. If they don't see that speaker load, then they shut off, protect the amplifier built into the radio. Well, this has 150 ohms of resistance built into it to keep that radio functioning. They also make an add-on to it. If that 150 ohms isn't enough, they make the Link LD that plugs into this that allows you to increase that so that it will turn that factory radio back on. Now this has a frequency response of 20 to 36,000 hertz with an extended range of 10 to 44,000. The speaker level inputs can take anywhere between 2 to 20 volts with a maximum 5-second burst of 40 volts. The RCAs can take anywhere between 0.5 and 5 volts of input. And then also when using the time correction, it has 9.45 seconds of delay. And since we're talking about delay, let's go ahead and talk about the delay here and what it's designed to do for your system. So to help explain what we're going to try to do with this time correction, we've gone ahead and made this drawing. This is the driver here. This is your driver's door speaker, passenger door speaker, and subwoofer. This is a 2-channel system. If you were going to do something with rear, you could use the gain on the amplifier to turn them down and blend them in with the front and subwoofer. We're not going to be doing that for this example. We actually have this same example set up in our car. Now a couple things to note. 1 millisecond equals 13.5 inches. We're going to be using inches for this one. There's digit 1, which is here, which is 1 millisecond. It has 9 adjustments on it. Every time you click it, it will move 1 millisecond. You have digit 2, which is here. That's 0.625 milliseconds. What this is going to allow us to do is work with fractions in order to get the right adjustment for us here, the driver. Now what we're trying to do is make all the speakers arrive here at the same time. This one's closer, this one's going to be faster than this one's going to be the slowest. So we need to do some math, because we need to move this speaker out to here, this speaker out to there. To do that, we simply take C and subtract it from A, and that's going to give us the channel 1 number. Once we have that, we're going to go ahead and divide that number by 13.5, and that's going to give us how many we need to move digit 1. The remainder of that, we're going to divide by 0.625, and that'll give us digit 2. For B, we're going to do the same thing. We're going to take C and subtract B, and then repeat the math. Now to get these numbers, we need to go into the car and measure from our head to the speaker. So let's go ahead and do that real quick. Now for this, of course, we're gonna be using the lab. And for those of you guys that aren't familiar with the lab, we have a series called Car Lab, where we actually show you. This is Fernando's car, and it has a bench in the back that we can go ahead and test all this stuff. So we're gonna go ahead and hop in, by that I mean Fernando, and I'm gonna go ahead and measure the distance. Try to be as accurate as possible. And remember, if your speaker is sitting into the door, make sure you add on those inches when you're measuring. So if you're just measuring to the grill and the speaker's sitting 2 or 3 inches back, you have to add that in, because it could change drastically the way it sounds.
Oh, really?
Now all you're gonna need is a simple tape measure, and make sure the person that you're gonna do this with is sitting where they're gonna drive. Now go ahead and take your tape measure and line it up where you think the center of the speaker is through the grill and measure to his ear. And remember, add in those couple inches. So we'll come over here and we'll write 41. Next is going to be 56. Now measuring to the subwoofer can be tricky, especially if the subwoofer is fired back. So you're gonna have to play with this one and get it as close as you can. Because that fires back, so it's like 65. 66. The subwoofer is 66. All right, so now that we know the distance, we can go ahead and do some of that fun math. Are you ready for math?
I'm ready.
Math is fun. So like we said, we want to take C and subtract A. So 66 minus 41 equals 25. And do the same thing, 66 minus 56 equals 10. Now we'll take 25 and divide it by 13.5, and that's gonna give us 1.8 something something. So that's gonna tell us that we need to turn digit 1. Now we'll go ahead and subtract 1 here, and that'll give us the 0.85 number. And now we'll divide this by 0.0625. That's gonna give us 13.6. We'll go ahead and round up and make it 14. So now we're gonna have to turn digit 2 14 clicks. So now we'll take 10 and we'll divide that by 13.5. And that's gonna give us 0.74. So now what we wanna do is just go ahead and divide it by this. And that's gonna give us 11.85, so we'll just call that 12. Now this is giving us the numbers that we have to turn these dials. So channel 1, we're gonna move 1 click here and 14 clicks here. Channel 2, we're gonna leave this at 0 and move this 12 clicks. That's gonna give us the proper distance so that these speakers all arrive here at the same time. But before we get to that, we need to get this into the car and we need to set it up for clip. So let's head over to the car and start having some fun. Now there's a couple ways you can test to see where your radio is clipping at. One of the more popular tools to use is this guy right here, the SMD DD1. But we know a lot of you guys don't have that. But digital multimeter with an oscilloscope built into it, like this guy right here, will also do the trick. Or if you just have a regular oscilloscope, that will work as well. Now what we're gonna do is we're gonna go ahead and I'm gonna have Fernando play a couple test tones, and we're gonna measure to see how far we can turn up the volume on the factory radio. Now knowing where the factory radio distorts at is very important, because that's going to tell us how far we can turn it up. The other thing too is the volume knobs don't work in a linear movement, meaning they don't start here and perfectly go straight up and like a 30-degree incline if you were to draw it out. They work in more of an arc. So there's a power band to where the bulk of the music, it's a very gradual incline, and then towards the end it goes up real fast. You need to know where this is at, because if you're tuning in that gradual area, you might not get any voltage out of the radio. You might need to go a little bit farther to actually get enough voltage to create a good sound. For those of you guys that have DD1s or are wondering how the DD1 works, it's pretty simple. You go ahead and play a test tone. In this case, we're gonna play 1000 hertz, and it has a couple lights on here. There's a distortion light, there's 1000 hertz to tell us that we're actually playing it, and then there's a signal. Now we have 2 test leads, which most of these products do. We're going to put it on positive and negative outputs of the radio. And so as you can see, we have the green signal, we have the blue 1000 hertz. Go ahead and turn it all the way up.
Okay. All the way up.
Alright, so in this case we're going all the way up and we're not getting a distortion. Now we also have this guy here set up. Just need to adjust the range a little bit. So what this guy is showing us is the 1000 hertz. As you can see, it's nice and rounded here. I'm going to fake it and show you, see how that squared off? If we were having a bad signal it would of course be smaller, but you would see a squared off wave like that. Now on this guy, it works basically the same. We want to figure out how much voltage is coming out. In this case, there's 2 volts or 20 volts. We don't know yet, so we'll go ahead and start at 2, and we'll hit display. Now we'll go ahead and grab our set of test probes, just like on all the other stuff. Now if it's beeping like this, that's telling us that we're overdriving it. We want to go to the next switch. So we went ahead and switched it to 20 volts, and now you can see the sine wave. We can go ahead and adjust it up and down in order to see it closer or farther away. But in either case, it's not squared off. This will do the same squaring that this guy will do. And what we were looking for is as you turn it up and down, go ahead and turn the signal up and down for me, Fernando. See how it gets smaller? Turn it back up. And it gets bigger. The bigger it gets, the more it's gonna wanna clip. So what we're trying to do is find out on the radio where that happens, and we're not gonna go past that number. In this case, we could pretty much turn it all the way up and not have to worry about it at 1000 hertz. And there again, even on this, we're still getting a nice clear sine wave. So what that's telling us is that we can turn the volume essentially all the way up from this factory head unit, and it's got a really clean output. That's good. That means we have a good place to start. Now that doesn't happen all the time. Now with a tool like this, which is a great tool to have because this is a digital multimeter and a oscilloscope, it's only like 70 bucks. You can test all that stuff. So there's no excuse not to have this to do the testing. Now the next test we're gonna do is gonna be using this guy here for clip output on this. Now for those of you unfamiliar with our lab, basically what we've built is we have a test bench here. We have some permanent amps mounted here in the back. We have barrier strips here with outputs from the radio. We have power and ground that come over on this side so we can hook up test amplifiers like this guy here. We have power and ground coming from the radio for remote turn on, constant 12 volts and accessory. This just allows us to test any form of equipment we want. And in this case, what we have is this amplifier right here, the Rockford PBR 400X4D that we're going to be using for this. And we're going to be running this in 3-channel mode, meaning we're going to put channels 1 and 2 on driver's front door and passenger front door, and then channels 3 and 4 are bridged to the subwoofer, which is perfect for what this guy was designed for, a 3-channel system. Now we've gone ahead and made up our wiring so that we can plug this guy in. We're going to be using, as we said, high-level output. Now the idea behind this test bench is to actually test stuff. We're not worried about how pretty it is, we're worried about how to use it. Now we have some Stinger 6000 series RCAs we're going to go ahead and plug into the output of this device, making sure that you get right and left correct. If you don't, the time correction isn't going to work properly. Then we also have our signal cable here. We'll go ahead and plug that in. It has a power indicator here on the side. Now we're going to go ahead and also unplug our speakers for right now, because we're going to do some testing and we don't need our speakers connected for that. Now what we want to do is go ahead and test to see clip. We're going to play that 1000 hertz track again, and we're going to turn the volume all the way up.
1000 hertz.
Now we'll go ahead and turn up channel 1 and look for the LED to come on. Now it should start to glow dimly and then go to full brightness. As you can see, dim and it gets brighter. And we want it to there we go. And we can repeat it on channel 2. Now, just because we've set both of these to what we think is perfect clip, that doesn't mean that the output left and right is perfect, meaning it's balanced. It could be off. So what we want to do is actually test the output voltages of these so that they match. And to do that, we'll go ahead and remove the RCAs. We'll plug in some test leads. We'll go ahead and grab our multimeter, make sure it's set to AC, and we'll test the output voltage. So in this case we have 7.79. I'll go ahead and switch to our other set. We have 7.99. So we'll go back to the lower set and we'll see if we can turn it up some. Oh, there we go. Alright, so we've got them as close as we can to matching. They're very sensitive, so it may take a second or two. But now both of our outputs are matched. Now the one thing to keep in mind is getting them perfect using the meter isn't the most important thing, because you're actually going to use these volume controls to adjust the level once you get the time correction set. So it doesn't have to be perfect. We just wanted to show you that you could do it. Now what we want to do is grab that sheet of paper that has our numbers down on it and go ahead and set these dials. Now for channel 1, we want to go ahead and go 1 click. This has a nice click to it. Then we want to go 14 clicks. 1, 2. Now there are little arrows on these little flatheads that have to be pointed at the zeros. Now we want to go 12 clicks on channel B. And I will say the clicks are very nice and they're real easy. It's not anything you're gonna miss. It's a solid click. And that's it. It's set up. You're done with that portion of it. Now you actually have to hop into the car and do a little listening. And as I said, you're gonna probably adjust the gain on channel 1 a little bit down because it's the closest one to you. And sometimes, in the case where you have a tweeter or something like that that's right there in your face, you need to gain it down just a little bit. So we'll go ahead and plug the speakers back into the amplifier and we'll take a listen. Now one thing to keep in mind when you're doing this is me sitting here in the passenger seat, it's gonna sound like poo-poo caca. All right, it's not made for this. This is a one-person DSP. Now, if we were doing something that had an up mixer and a center channel and all that, which we're not, then I would be able to enjoy it. For me, sitting in this seat, it's just gonna sound like the passenger side door is really loud. But for Fernando, he's gonna have a totally different experience. What that basically means is once you get your timing all set and ready to go, if you want someone to demo the system for you, they need to sit there, not here. I'm sitting here because he's gonna tell me if I need to go turn it up or down on that level, meaning that channel 1 right there, which I know I'm gonna have to, so I'm not getting comfortable. But we're gonna go ahead and play some music and see what it sounds like. Now make sure when you're picking a song, it's something you're very familiar with, and preferably something that has a really good vocal track, because what you're trying to do is get the sound to come out of the center of your dash, not the left or right or anything like that.
When the world is cold, you're lonely. There is nothing fear upon never change.
Now naturally you're not going to be happy with just one song. Playing something like Frank Sinatra is something he listens to a lot when he's doing this, so yay. But we're going to go ahead and play a couple more songs because we just want to make sure. Now a couple things to keep in mind when setting this thing up. Channel 2 output voltage is the most important. You want to make sure you're getting the most output voltage on channel 2 because you're going to be turning down channel 1 and it's on a sliding scale. So if 2 is maxed out, then when you turn, you'll keep it, you understand what I'm saying? So you'll reduce this, but you're still going to get the most sound out of it. So like if you were to kind of channel 2 and then match up channel 1 to it, it's like and then so you want to make sure you're getting the maximum amount of unclipped clean signal out of channel 2 because that's going to be your loudest channel. Now your subwoofer should sound, it should be moved forward. When you're listening to this type of music, it should be moved forward. You should be able to hear it up here and not just pounding from the trunk. Now if you got something like a 15 back there, it's going to sound like it's pounding from the trunk. So we have an 8.
Yeah, we have an 8.
So it's not going to be, we're not pounding out of the trunk. We want that bass to come forward. Now when you turn the bass up, yes, it's going to sound like it's coming from the trunk, but when you're trying to sit here and listen to it like this, it should sound moved forward. Okay, that's the idea anyways. Now that's it, that's all you have to do. Now don't be afraid of that math. We've made that as simple as we can. It's a couple of subtraction, a couple division, it's no big deal. All right guys, so that is the Link T. This is a really fun piece to have, to play with, to just get your foot wet in time correction. You'll learn a lot from it for sure, but in the end, it's an amazing sounding product. So in his car with that 3-channel stereo, we were able to put that thing in and immediately get a result that we're extremely happy with.
And you're surprised how
easy it is.
everything comes together.
Yeah. So if you're used to driving, sound, and you want it to be, yay!
Yeah.
So check this product out and look forward to the next reviews that we're gonna have on the Link Q and the Link D. You guys have a great night as always.
On to the next one, guys.
Bye.